example 10, we are told that find the set of values of x for which 12 plus 4 is greater than x squared. And I want to believe that we have understood what happens in example 9, and we are going to again arrange these terms in such a way that on one side we have a 0, and of course everything, the whole of all these go to the right, and we left the 0 there. 0 is greater than x squared. The equation is not 4 plus 12 plus 4, is 12 plus 4x. There is a 4x here. So 0 is greater than minus 4x minus 12. If you may want to make this one look a bit presentable, we simply have x squared minus 4x minus 12 is less than 0. We've changed nothing. And at that point, we must be ready to work with the equation x squared minus 4x minus 12 is equals to 0. And we are doing this so that you can find critical values. And the critical values here are simply 6 and a 2, minus 6 and plus a 2. Because minus 6 times 2 is minus 12, and minus 6 plus 2 is a minus 4. So we have x squared minus 6x plus 2x minus 12 will give us 0. Common factors in the first two terms is x minus 6 plus 2, x minus 6, giving us 0. So x plus 2, x minus 6 will always give you 0. And in this case, x is equals to minus 2, or x is equals to positive 6. And these are the critical values. But because we were not solving a quadratic equation, we were solving a quadratic inequality, this one, we should again go to realizing or familiarizing ourselves with the original quadratic inequality, which is this, and try to sketch the graph. Of course, in this nature, a is a positive, and when a is greater than 0, we will always have a U shape of a graph. So if we attempt to sketch it over here, we have the critical values negative 2 and positive 6. And because a is positive, then we are going to have a U-shaped kind of a graph. A U-shaped kind of a graph. That is our graph. And that we go back to examine our nature of inequality. And our nature of inequality, and this is where, this is the main thing that students must learn. The nature of our inequality is that everything on the left should be less than 0. That means our graph makes sense when the value of y is less than 0. That means what? For the part of the graph that is below the x-axis, that is when our y is less than 0. So in all this region that is rather continuous, and you can see it, the values of y are less than 0. So it makes a lot of sense, and it satisfies this inequality. And there's a bit of a difference between this example with the previous example, example 9, which we have just solved in the previous video, that our wanted region is continuous here. In example 9, our wanted region was broken. It was this part and that part. But if you look at this, our wanted region is continuous. That means what? For this to be truthful, then we are saying x has to be greater than minus 2. because when we have minus 2 and x tends to be greater than minus 2, then y tends to be less than 0. And the same x is less than 6, because when x is less than 6 again, when x tends to be less than 6, you can see where the value of y gets. When x is greater than minus 2, again you can see where the value of y gets. It makes a lot of sense as far as this function, which is less than 0, is concerned. But because our region, our wanted region, is continuous, then we can combine the two inequalities to form what we call a compound inequality. X being in the middle, it should be greater than minus 2. The same x should be less than 6. This is only possible when the region is continuous. You remember in the previous example, we had two sets of inequalities because it was not possible to put them this way simply because our regions were broken, unlike this one, which is continuous. And therefore, example 10, this is the solution for all values of x between -2 and 6, and the limits not included. It makes a lot of sense. That is exactly what we need to understand. We are not going to give x is equals to this exactly. X is equals to -2 or x is equals to 6. Those are called critical values or boundary. But it is inequality, and we should give answers that are representing a wide range of possible values of x. Okay?